Uh, this is going to be a pretty big talk. Level generation using machine learning. This sounds like a pretty great thing. Definitely, a lot of people want to experiment with it. I like to think of it as a form of magical fantasy problem solving. I think that the level of anticipation for what you're going to get out of these systems is absolutely preposterous. I think I'm going to give you like a really big review of how this is being used, how to get started, other research, and my experience as somebody who's doing this for some commercial games that are going to ship in the short term, and as a researcher recently from MIT who used some technology to kind of, really explore the fantasy part of generating levels. And if you don't know what machine learning is, I'm going to put it really simply for you. It's about teaching a computer using data. And there are a lot of different ways you can do that. The most interesting kind of detail about this is there's a trade-off. If you want to do this well, you need either a lot of data or there's some methods that use very little data. The trade-off is it's about telling the computer what's important. It's about knowing how to learn or giving it additional tips or instincts, I like to think of it, that help the computer learn the most from your data. This trade-off kind of characterizes the field of machine learning, not just for content generation, but very, very broadly. And for many of you who have tried this, you're going to recognize some of these things. You're going to have heard of maybe approximate Bayesian computation design for the very first time. A lot of this kind of exists in a very flimsy research realm or an experimental realm, but you'll see kind of in the upper left corner, like these are concrete things. If you have lots of data and you tell the program what's important, you can do great ad tech. You can make a ton of money selling ads and high energy physics. The kind of lots of data, you tell the program a little bit more what's important. This is like automotive artificial intelligence applications. A lot of folks, for content generation, they're in the upper right corner. You're not really telling the computer what's important for something like recurrent neural networks. You're giving it this really broad intuition, but you generally need a lot of data to do it well. And then a lot of folks use natural language processing. You know what the rules of grammar are, and if you've specified them correctly, it doesn't matter if you give it a corpus of 10 words or a million words. It's going to work if what you're interested in is generating English text. So this trade-off is pretty important. And all the way in the lower right corner, that's like strong AI. We don't have anything that discovers what's important and works with very little data. That just doesn't exist yet. This is a big presence, these techniques that Rogue sell. We saw Caves of Cud. Actually, they, for some levels of some aspect of their level generation, they use a tool that we're going to see that you could genuinely call a machine learning technique that's really fascinating, but definitely talk to them afterwards to get kind of the most concrete details on how that works. We also saw Botnik, which uses natural language processing, n-grams, a way of generating grammatically cohesive text. Again, that's way deep in that lower left corner, like something that you don't have a lot of data for, but you tell it exactly what's important, you get great results. And they definitely experimented with character recurrent neural networks. We're going to see that later to further flesh out this system. We also saw computational Fleurner generating that poetry, recurrent neural networks. Max Kreminsky actually works in a department that does a lot of content generation in video games. That does a lot of research there. You look at his pots and microsites. He uses a lot of different stuff. Same with Darius Kazemi. Went on stage, said, "We don't use machine learning." For him, NLP, that's ConceptNet. It's something again that kind of fits in that scope, but occupies this very good and very powerful niche. We also have Ian Holmes. He uses these games and microsites. He's going to show cellular automata and a set of heuristics to generate things like game levels and visuals and text. If you look at mainstream commercial games, they tend to not do content generation at all. Something like League of Legends or some kind of unsupervised machine learning, this very sophisticated technique to analyze the client that downloads a copy of your game. Clash Royale matchmaking is widely believed to use a system to matchmake people that's more sophisticated than just your skill. And then when it comes to ad tech or making money, this stuff really shines. It's not really of interest to us, but this is really in the kind of commercial gaming. It's absolutely all over the place, and it's you know, some of it is really old, like from 1987. The tools that people use to do advertising targeting it's very advanced in machine learning tools, but it's very old. And this kind of puts us in a very different world of where are we going to see this. Uh, you know, all the way on the left, content generation, you tend to look at these more experimental caves. Caves of Cud, it's in this really cool, like, little spot where they're really on the vanguard of using something that's a little bit off the beaten path to generate levels. You look at AAA commercial games, basically, you know, the bigger the title, the more likely it is. They're just using this for ad tech, something that resembles monetization, optimization. I guess my point is research is way ahead of commercial games. So don't expect to find like a big GDC talk about, you know, how is this being used in my huge game, because it's just so far off. But definitely there are a lot of experiments. That's kind of what I want to share with you. Some of the key researchers in academia are doing this. Michael Mateus, he's in Max Kreminsky's department at UCSC. He does a lot of different research specifically on level generation. One of his graduate students did that work. This guy, Julian Tegelius at NYU, also does a lot of fascinating research. And Dan Ritchie, who was a Pixar technical director, now a professor at Brown, does really fascinating graphics generation. And you know, in graphics, big problem in roguelikes. And if you think more critically about what does making a compelling level really mean, it can often mean making something that's pretty. And I think, you know, if you want to see something cool, you should check him out. There are a lot of influential demos. A lot of people saw this unreasonable effectiveness of recurrent neural networks by this guy, Andrej Karpathy. He now works in automotive artificial intelligence. People saw this. They were instantly floored. They use it for a bajillion different things. This is recurrent, character-based recurrent neural networks. That's what he wrote. This thing, Wavefunction Collapse, we'll see this demo. This is texture synthesis. This is what Caves of Cud experiments with. I want to show you this fantastic animation, phase function, neural networks for character control. We'll see that demo. It's fantastic. And deep dream kind of hallucinations of a neural network really started a lot of interest in using machine learning for content generation. Kind of predates all of this work. The major techniques, you know, this is we're going to explain what these concretely mean, but it's basically different ways of looking at the problem and what you're telling the computer. What you're telling the computer is important versus how much data you have. And texture synthesis, make a picture, treat a level like a picture. Maybe you showed other pictures. It learns how to make pictures or like the picture you showed it. Recurrent neural networks, treat the level like something you explore over time and make the assumption that the future should resemble the past. And this is a really, really important intuition that works great for level generation. And finally, there's Monte Carlo Markov chain design. There's this thing, HMC inference. It's when you can specify things that you know are important, like a level should be symmetric. I'm going to talk about that. Or maybe it's your room should have good layout. And it will keep trying to generate levels until it has a process that makes stuff that fits those measurements. So it's a really fascinating kind of in-between that, you know, people kind of do automatically. Every single roguelike today that uses heuristic level generation is really a special case of Monte Carlo Markov chain design, where you have just decided, like, this is kind of what I want, as opposed to the computer figuring it out. So let's look at some of these demos. Wavefunction Collapse. This is a video of a generator that somebody made over 3 dimensions. This started with a layout of what a city tilescape should look like. And you can see me kind of editing, like I want to remove some blocks and give me reasonable geometry that fits it. There's some constraints, like, oh, you know, certain tiles can only be adjacent to certain other tiles. That's what makes it look pretty. But what makes it look natural is this system. It looks at other examples of, like, what your voxelized city should look like, your voxelized building. And it tries to make things that if you kind of blur your eyes, it'll still look the right way. You'll see some great 2D examples of this online, and this is something the Caves of Cud guys, you know, they'll talk to you about how that works. For Super Mario, this is from a different website, but this is research that Adam Somerville at UCSC did. This was generated by character-based recurrent neural network. All that system knew is that I have some text representation of the level and that the future part of the level somehow is related to the past. plus my fuzzy picture of everything that's going on. It makes this really, really reasonable Mario level. Like this is playable. This is pretty good. I'm sure it was curated, but it didn't know anything about the rules, didn't know anything about jumping or difficulty. It just kind of looked at a bunch of Mario levels and made something that, given that assumption, is pretty good. I want to show you this neural network animated character. I think if you want to make more accessible roguelikes, you have to start thinking about art very critically. Nobody animated this. This wasn't programmed with all this IK. I don't know how many people are familiar with 3D animation, but this is an absolutely stunning film level quality animation. All you're giving as input is your controller, and a neural network is generating the movements of the arms and legs. It was using motion capture data, 30 hours of it, to understand how people move, but you can watch this guy just explore his space completely dynamically, and this is just mind-blowing. This is better than Assassin's Creed, and was made by 3 people. And you're going to see later, let's say your level generator, it's height maps. The character can interact with your height map world, super realistically, runs into walls, climbs your staircases. This you can use in a game today if you look carefully, and I can definitely help people who are interested in doing that. I want to show you also Dan Ritchie's work. This is a Spaceship Generator. I give it this blocked out spaceship, and then it generates, finer detailed spaceships for it. If you really wanted to approach art, his methods, MCMC methods, they're going to be the main way you do it in a way where you as a designer can guide exactly what you want and get these really fascinating generated results. I also want to show you an MCMC method where you put stuff in a room and it uses interior design logic to lay it out in a pretty way. You'll see this system work over time. A lot of people want to stop making games that use tiles, but decorating a room when you don't have tiles is really challenging. There's actually software that can help you do that. So, think about the future, next 5 to 10 years. This is going to be a big part of creating a, 3D action roguelike experience. You're going to use procedural generation that really references this work from 5 years ago. So let's talk about how you would concretely use it. This is going to be a whirlwind tour, but I really want to give you a super important objective. This is how I've found great success in using machine learning for level generation. I really focus on making stuff that looks like it's made by hand, not by a computer. This contrasts really significantly with the heuristics that people use, because you kind of eyeball things to look like they're made by hand, but it's very rare. It's very, very difficult to achieve something that's computer generated that looks like a human being made it. And I'd like to reference this platformer that very ambitiously set out to make difficulty the one parameter that defines the levels that are generated there. And it's an amazing game. You should try it. Cloudberry Kingdom. He worked on it for 3 years, thousands of hours. I wish, you could do it in 3 hours. But when you look at the levels, they obviously look like they're made by a computer. But he had a very specific objective in mind. So, how do you look to the future? I think, Jordan Fisher has solved the difficulty problem. Let's talk about, making stuff that looks like a computer. Really means rejecting difficulty as your parameter. Roguelikes are already hard enough, so don't sweat it. So one of the things that people like to make, some of you have seen these videos, all you're doing in this level is just pressing right, and Mario he explores this level automatically, the human built. But it's really, really fun to watch, because it's kind of subverting this idea that a level that looks like this, if you actually tried to play it, would be so impossibly challenging. But it's just fun. This is something that's made by a person that looks like it should have been made by a computer, but that we really enjoy. So I think, level generation, think outside the box. This is something that has literally 0 difficulty that's really, really fun. One of my favorite levels that really does this well, best levels in any platformer ever made, this opening scene to Sonic Adventure. You're literally, I guess you're snowboarding down asphalt, and There's some really awesome music that plays, and you're in this theme park. You know, you're on in a many ways a roller coaster, figurative and literal. Like this is something was made by a person very lovingly and very carefully thought out. Like I think we should aspire to make stuff like this. Try it. It's like so refreshing, so good. Really comes down to, you know, best difficulty. Sometimes it's none. Random placement, especially kind of organic feeling random placement. This is kind of playing a little slowly, but this is a game where you just move the ball left and right. You can watch me play. Everything's kind of placed a little bit off, like very organically, but you can tell that it's procedurally generated because it's kind of this random placement. When things are made by people, they tend to have symmetry. They tend to have this certain pacing and kind of regular features. This is a tile-based game, you know. Roguelikes are tile-based games. Use that to your advantage. Make stuff that looks symmetrical and feels paced, because that's what makes it feel like it's made by hand. And actually expressing symmetry, it's really simple. It's something that you'll see later that I've experimented with, that you can definitely express to these different techniques, make it work well. This is Binding of Isaac, which I think uses symmetry beautifully to convince you that these things were handcrafted. You can see on one half, you know, that's my negative x. On the other half, that's my x. I could just take the left half of the screen and flip it. And that mirroring gives me something symmetrical. Whereas if you place the rocks where the dotted circles are, you know, it just wouldn't look as good. It just wouldn't feel like it's made by a person. If you use overly precise numbers, I think that kind of undermines your ability to make something feel like it's made by a person. This was made by a person, Clash Royale. The numbers in the game, they are made by human designers, but they feel like they're triangulated to like stiff you, and that's definitely people's experience with a lot of free-to-play games. Like, if you use numbers, if you have 3 digits, you know, it's instantly telling you like something's procedural or something's like really too fine. It feels too triangulated. I like to contrast this with, say, you know, Hearthstone. This is a card game by Blizzard. The numbers that appear on this card, I don't know if you've ever played Yu-Gi-Oh, but the numbers have 3 digits. And in this game, numbers have 1 digit. And you feel like there's a lot of important consideration, like why is it 211 whelps? Why is it a cost 462? Like, you feel like a human being thought about this. And it just came from using really small numbers you can kind of reason about. I want to talk about how would you actually model a roguelike? You know, we've seen what the objective is, make something that feels like it's made by a person. I think something that really unshackles you is you got to think of it as a 1D platformer. All you make is a decision to go left or right, and time kind of brings you forward. This is easier than treating things as 2-dimensional. It opens you to basically every machine learning tool that exists today. It just liberates you. And one example would be, well, in a Mario level, you sort of only go forward. Sure, you can explore backwards, and that's just part of the rules of the game. But for the generator that Adam made that was really successful, it used a technique that assumed you sort of only go forward. It just happens to work. So, you know, try it. Always try it. For something like Binding of Isaac, you know, it would be more challenging, but there's a way where you can express a 2D level as multiple 1D levels. And you'll find that just with maybe a little heuristic to tweak it, you'll end up with something that works to generate 2D levels that's explored in this sort of way that was generated by a computer and used a lot of different tools. You need to collect data, right? A lot of the techniques I showed you on that big cross slide, you need data to make these systems work. You can rip data from existing games, you know. Don't necessarily commit yourself to the multi-$100 million project that Facebook and Google has to collect data to really do the science of what they're doing with on the vanguard of artificial intelligence. There's a lot of content that you can already rip, especially for stuff like art, but even for levels. You know, I went through 5 different games, 6, to really see, can I extract data? Can I do something with it? And I succeeded for all of these. All of these really fantastic games, you know, they use different engines, but there's a way, because of the modding community, that lets you get to the data. And even if you train these systems on, like, this is a raw level out of Geometry Dash, you know, it can look at this hexadecimal, and it can create working levels you can copy and paste into Geometry Dash and play. It's absolutely fascinating. So definitely put in the effort to try it. There's free data everywhere. when in terms of libraries, there's always a lot of different technology being developed in a lot of different systems. I'm going to take a very mainstream view. Use TensorFlow. It's going to kind of be the future of what a lot of academic work is done in. It's super flexible, supports a lot of languages. It's got huge commercial backing. It's going to kind of subsume a lot of different work in a lot of different places, and it has a lot of the best examples. What I want to specifically talk about, what I've had a lot of success with, is these LSTM models. This is recurrent neural networks, character neural networks, Andrej Karpathy's blog, stuff that people are already using. I want to talk about, some of the details, because this stuff, it's really challenging and time consuming. You're not going to get like, you're going to get something just like, as Mike artfully said, like that you could curate to make really good. But if you want to achieve like a real-time experience, we all know that's going to be super, super challenging to produce a 99% hit rate instead of a 1% hit rate. And I want to share with you like some of the things that you can do for level generation specifically. A lot of this comes out in my commercial work to get something successful. Ultimately these tools are a miracle. You're going to get a lot out of them. So let's actually first understand how they work. Like I said, you have this big chunk of level, and you're just trying to predict. You're just trying to like say what tile would go in this green box. And this system is so powerful because it remembers something about which tiles are adjacent to other tiles. That's my simplified explanation. If you follow tutorials on this, there are people whose full-time jobs is teaching this. Like, go with them, but this is just to help you understand. Our goal is we look at this level and we want to see what goes inside that green box. There's something called a loss function. This is like how do you tell the score? How do you tell the computer how well it's doing? And I'm going to regularly say minimize loss. That means improve the score. That means make it do its job better. One of the first things you'll notice, this stuff is super buggy online. It's really, really crazy how many of these implementations are just totally abjectly broken. I'll give you an example. Public implementations of character RNNs, they make this very specific bug. You're going to see it illustrated. It exists in stuff that was just 6 months ago in super well-exposed mainstream code that people download and use online. Specifically, it's like misunderstanding some detail in Python. You'll see this is the correct code, April 2017. June 2016, if you duplicate an array like that, you're getting a reference to something a certain number of times instead of making a copy. This stuff has pitfalls, but this was 6 months ago. If you tried using this thing, if you were maybe the botnik folks, and you're like, oh, this is a big ambitious thing, you try a piece of code online, you're like, ugh, none of this works. Well, it could have literally been buggy. And it's just so stressful. It gets fixed, but it's really like you'll discover these things and like, man, actually, this could have possibly worked. There's a lot about like dividing. How do you think of a level? What makes up a chunk of a level? There's a solution here. We'll post the slides online, or you'll read about it more. But you can 10x the performance of your algorithm. This would be a correct way of interpreting a Mario level, in my opinion. Some of UCSC research, discovered that if you snake along the tiles, you'll get better results. If you say like the way that you look at time, you start at tile number 1, and then you follow that snake, and then finally you end up at that green tile. This is a very valid interpretation. You need to use special code to like use chunks that are differently sized, but it all exists. This is if you just download Andrej Karpathy's stuff off the internet. It kind of looks at the world as these kind of unevenly chunked things that doesn't really, you don't really care about predicting a sky tile. You have to really look at this stuff critically to make sure that it's going to be doing what you want to do. Encoding is a big problem. How do I turn my data into something these systems can understand? Something I've found very successful. I'll show you an illustration of this, but this can 20x the performance of your level system, level generator, performance in terms of, would this be something that if a human guessed what should go in your piece of level, what would that human designer put? This is a Mario level. You can represent it as a piece of text from a great little blog. You can see like P characters mean pipes, and equal signs mean ground, and this dash means sky. But that's a lot of different characters for the system to understand. What if I said I'm going to categorize my tiles, and I say they're passable tiles, they're interactable tiles, or reward tiles. So maybe a coin block, it's just a reward tile that's interactable, whereas a breakable brick is an interactable tile that's neither passable nor reward. Okay, and I look at my world now as ones and zeros instead of a bunch of characters. This is what a Mario level might look like if you just consider, is it passable? And you'll see, like, oh, I can make out the platforms, I can make out the ground. Something makes sense to you. You know, you can look at it, you can instantly tell. There's a problem, though. If you look at the rewards, you know, where the coins, like there might be just 2 coins in this huge sea, you know, of nothingness. And these systems, they don't work with rarity very well. So, you know, you might be able to characterize your data in a way that makes good semantic sense, but it kind of has these, like, oh, it's this noise that's lost in the sea. There's no way that this stuff will learn it. There's a little trick that basically reduces to, well, what if I record which columns I saw interactable stuff or which columns I saw rewards? And now, you know, I've 10x'd the amount of ones that appear, even though doesn't mean the same thing, but these sorts of systems, just giving them more data, hacks that you might be able to reinterpret with some heuristic, you'll get something that works a lot better. This is actually called a convolution. It's beyond the scope of this presentation, but when you look at like real breakthroughs in machine learning using recurrent neural networks, they tend to integrate some kind of convolution, some way of reinterpreting the data that helps turn noise into something that's big that it can see. Also lets you train across multiple games. So if you want to make a platformer that uses data not just from Mario but a lot of others, you know, you'll have to kind of semantically interpret what you're looking at. I think the biggest problem is noise. You know, you generate this stuff, and if it isn't a human being curating it, whether it's text and you just get like nonsense grammar, or it's levels and it just puts blocks in random places that you didn't want. Like you just look at it and you just feel, because it breaks some rule of interior design or architecture, it's just like, oh, this is so noisy. There's a trick, you know, denoise your level. Treat it like a picture. Use just like you do in Photoshop, get rid of the noise. Or you can do something that's really sophisticated that gives you some more stuff too. I'll show you what this looks like. This is what it really means to denoise. If you look at the images on the right, they all have, they're all wrong by the same amount relative to the reference, even though qualitatively they're images that look a lot better than others. If I just naively say how different is images along the circle to the image in the middle, they're all the same difference, but definitely that upper left corner, you know, it looks the best, and in the lower right corner it looks the worst. Level architecture has the same sort of features. You can use a method that says, well, I want to kind of drag these like random 2 bricks that might have appeared in the middle of my level. I kind of want to push them against the wall, and then maybe you have some heuristic that turns them into bookcases. You know, it's something that works, and it's a more sophisticated way of looking at your data. There's also this idea, well, you know, the clean part of my image is the mirror. And I want to both get rid of noise and I want to make it more symmetrical. So I just say, tweak the left half to make it look more like the right half if you're only removing noise, not by changing anything else. Fabulously powerful way to get architecturally cohesive levels using recurrent neural networks. Something you might encounter finally, performance is poor. You know, this just takes a long time to run. Actually, in my experience, because there's so little data, don't go with big optimizations. Don't do stuff that's too complicated. Like, just try to get something that looks good and be patient. You can actually download off my website a build of TensorFlow for Macs, for GPUs. They don't support it anymore. You can get my build. It's also shared in like various issues on TensorFlow's GitHub to just see, you know, maybe you do have this performance problem, download that software. But I don't think level generation is it's not really what's going to make a difference. Like, how do you generate monster behaviors? Or how do you generate, you know, not just the text, but something that has functional game rules? You know, has something that has to do with the code. It's called functional game content. This is what I've been really experimenting with. You'll see this in an example of something I'll release to you guys, which is just generating cards, functional playing cards for Hearthstone-like games. Something that I think they're totally different methods. use to generate something that's functional. A Hearthstone card is really just a monster in a roguelike in disguise, like the way that it behaves. And this is something that I hope to share with the community very shortly to just kind of advance really what is the next 5 to 10 years. I think it's functional game content. And if you're still really lost, just talk to me afterwards. But ultimately, I would say the mission is make it look like it's made by a person, not by a computer. That's what's going to get you the most out of these systems and really clarify your goals. Functional game content happens to be that thing that right now you need game designers to write the behavior of the monster. And you have to think, like, how will that be generated? And that's really what I've been working on. I think it's the future. And, I invite you all to talk to me afterwards, but that's machine learning in a nutshell for level generation game content in total. Thanks so much.
We have time for a few questions. Yeah.
Hey, thank you. I don't want to get lost in the weeds, but could you talk about the snaking concept again? You were searching tiles in a snake pattern, and then you just kind of stopped, and then you said, this is better, and I could not suss out why.
Yeah.
Thank you.
Yeah, so why is snaking better? There's some hypotheses. If you read the paper that I got it from, this is the Mateus advisor in University of California, Santa Cruz department. They speculate a little bit that maybe snaking, looking at things in a snaking pattern as opposed to just as a linear structure, tells you more about, like, you can actually pull up the slide here where you'll see this, but it tells you a little bit more about what's important. So in this case, it's important that the green tile, if you follow this line, you catch at the beginning, like, oh, there might be 6 sky tiles, and you'll see 6 sky tiles appears a lot, and it might learn to count the number of sky tiles, and it's like, I've hit 6 sky tiles, and now I place something. Sometimes I place a brick, or if it's sky, and you'll just see that if you count along this line, it's easier for the designer to come up with a rule, like after you've counted this many times, place something here, like make a decision. That's a big part of what recurrent neural networks learn to do. They learn to count. I think snaking helps it count. And that's probably the core part of why this little innovation that this academic paper did vastly improved the performance on generating Mario levels.
Sorry, just following, it seems like there's potentially some overlap between that and the other idea you mentioned about introducing some kind of CNN or some kind of convolution into each column. Do you know if anyone's tried doing that, sort of wiring a CNN into an RNN and building a level?
That UCSC department actually is researching how do you apply platform levels for multiple games and reinterpret the levels so that you can train a system that's seen multiple games. They do the convolution, this idea of changing like some bigger block of data into something simpler by hand. They do it, they adapt their own data. They're essentially doing a convolution. You can have a system that does this automatically. But Max, he actually is a researcher there. He's going to be talking later. It's something that I think he'll be able to speak to really precisely.
You said something about a pity system for loot.
Yeah.
And I had never heard that idea before. So could you fill me in?
The super short of it is, if you didn't unpack an awesome item after trying 40 times, the system feels pity for you and gives you an awesome item anyway. So even if it appears to be random, it subverts and reinforces it subverts the gambler's fallacy, which is usually, as a gambler, you think, oh, well, I've lost so many times, I'm bound to win. And in a video game world, well, you can actually make things work that way. That's what a pity's algorithm is. So if you're a human being who has a gambling problem, pity systems are kind of they're your OxyContin. They're really going to make you addicted to what they're giving you.
I have a question about kind of like your very end. Your last slide was like, the goal of this is to, we should make them, do you mind pulling up? It's like, make it feel like it was made by a person, not a computer. And I guess I'm wondering why actually? Aren't we in an era where we're adapting more to, I don't even know what the word is, but aren't we adapting to this where things are made by algorithms and that's becoming the new normal? And I understand maybe like a feel, which is really hard to categorize, and you were talking about like symmetry and things like that.
Yeah.
But maybe we're actually becoming more and more used to it, and I guess I'm kind of wondering about that. Why that's your, your end kind of judgment, I guess, on it, or what you're
Because
thinking.
I think when we look at like really influential examples of computer-generated content, it almost always involves some form of curation. And you could say that it sort of disguises the fact that these systems might make stuff that doesn't feel like it's made by a person 99% of the time, but 1% of the time it does, and a human being actually went and picked it out. You could call that making something look like it's made by a person, but I think if you want to hit that 99% performance level, you have to think about, like, how am I curating? And the systems that do that, they're really going to push the envelope on research. So definitely as an experimenter, I'm interested in that. But you're absolutely right that people are, that catch-up game with randomly placed obstacles, it's enormously popular. People are satisfied with that from a gameplay point of view, and roguelikes are definitely a testament to, you still have something in the gameplay sense is very appealing. So it's definitely a complicated question.
Great. Thank you so much.